Welcome to Get Your FRQ On. This question is from 2004. It's question 2, and it is calculator active. In the question stem, we're given two functions, f and g, and their graph. As I recall, f of x is 2x times the quantity 1 minus x, and I believe g of x is 3 times the quantity 1 minus x times the square root of x. And based on the graph and analyzing the functions of f and g, it should be the case that f and g intersect at 0 and at 1. And we just want to find the area of the region enclosed by those two graphs. All right, so it doesn't really tell you in the graph which function is which, so you do have to go to your graphing calculator, graph these two functions, or at least use some other kind of analysis to determine which function is which. But you have to know which function is on top and which function is on the bottom. In this case, the function f of x is greater than or equal to g of x for all x between 0 and 1. So the area of the shaded region is given by the definite integral from 0 to 1 of f of x minus g of x dx. So the integral from 0 to 1 of 2x times x minus 1 minus 3 times x minus 1 times square root of x dx. And this is a calculator active question. You are not expected to calculate the value of this integral by hand. So once we've written down what integral we are going to ask our calculator to do, we should be in the clear to go ahead and do that. The area of that region is 1.133. In part B, we are asked to find the volume of this solid when that region is revolved around the line y equals 2. Now, since we're revolving around a horizontal line y equals 2, our outer radius will be determined by 2 and whichever one of those two functions is further away from that horizontal line. In this case, that happens to be g of x. And then our inner radius will be determined by 2 and the function which is closer to the horizontal line y equals 2. In this case, that is f of x. All right, so since g of x is less than or equal to f of x on this entire interval, in this case, because the line y equals 2 is above both of these functions, g of x would be the furthest one from the line y equals 2, so that will be our sort of outer radius, our big radius. And our inner radius would be 2 minus f of x. So the volume of that solid can be found by taking pi times the integral from 0 to 1 of 2 minus g of x squared minus 2 minus f of x squared dx. And again, calculator active, we're not going to do this one by hand. We've communicated what we're going to ask our calculator to do. So let your calculator do it. The volume of that solid would be 16.179. In part C of this question, we define a new function h of x to be a function of the form k times x times 1 minus x. Then we are asked to write an integral which could be used to solve for the value of k, given that the volume of the solid, when cross sections are taken perpendicular to the x-axis, are squares, and that the volume of that solid is exactly 15. Now, one thing to understand about this is we do not actually have to find the value of k. We are only asked to write an integral which could be used to solve for the value of k. So here's what we're after. Basically, we want to set up a volume by cross sections integral that is equal to 15. So basically all we're doing is we're going to write a volume by cross sections integral, and then we're going to include equals 15 or 15 equals. All right, since each cross section perpendicular to the x-axis is a square, the area of that cross section would be given by the area function a of x, which would be k times 1 minus x minus g of x squared. All right, so that would give me the area of that square, and all I have to do now is set that equal to 15. Notice that there's no pi in this integral because we're not revolving anything, and cross sections are not semicircles or anything like that. So there's no need for pi here. There's nothing circular about this. So once we have the integral set up, we're pretty much done as long as we have it equal to 15.